on Bentley's iTwin plugin for Unreal, which streams massive construction data using Cesium 3D tiles. And they're going to go over some of the use cases and also do a case study on the UK's big railway project, which is the HS2 project. So let's give them a warm welcome.
Okay.
Yeah, that's good.
Is this one here? Cool. Okay. Good morning, everyone. Nice to see so many people here around. Before we're gonna start, I'm pretty curious, or we're pretty curious about like how many people already used Unreal Engine.
Anyone?
Here's some
people.
Okay, cool.
That's good.
Nice, great. Cool, so we want to give you an overview about like why we developed a plugin for Unreal Engine, especially about what's possible with that one, and in particular about like what's possible with it with Cesium itself, giving you a more deep dive about the backend and what's behind there, and where you get it for free, and also like a future outlook on what we're currently working on. So I'm Marcus, I'm here with Danny, my colleague. We're both working for Bentley Systems. And we have a background of game development, software engineering, and design. And yeah, to see a bit more in detail about like how our customers are using our technology, we have Morten Price. Unfortunately, he can't be here in person, but we're gonna see a recording of him like presenting an amazing project he's working on for a few years already. So let's give you an overview of Bentley. So Bentley is an infrastructure software company where in the field of architecture, engineering, construction. And in Bentley, our main goal is to empower the people to design, build, and operate a better and more resilient infrastructure. And our customers are working on like one of the biggest, the largest infrastructure and most complex infrastructure projects of the world. That can be bridges, roads, dams, train tracks, wind farms, airports, all the way down to fusion reactors. We're gonna go in detail there a bit. So you can imagine they're like heavy data sets they need to work with every day, and they're working on really huge 3D models. Within Bentley, there is called the iLab, where we're both working in a digital innovation lab, so one of the Bentley systems innovation teams. So we say we prototype the future, this is our claim, and we're doing that one with Unreal Engine. So a few years ago, a customer called Brigantium Engineering, they contacted us and they say like, hey, we need to produce every 2 weeks, like a new sequence of what meant to be built for the future, right? So every 2 weeks they have like a lot of work to do and want to visualize that one somehow. And they're working here with like a massive construction project. And a massive construction project has also like a massive heavy data sets. And this construction project is called ITER. ITER is a fusion reactor in south of France. So they're trying to challenge how to bring fusion reaction, that's something that the sun is producing, down to Earth and to produce green, carbon-free energy for us. It's in south of France with 30 plus countries working on that one, modeling with like millions and millions of polygons in different softwares together. And we wanted to enable them to interact with huge data sets here on standard issue hardware. That was very important. So nothing crazy, something that you can afford as a contractor, as a company pretty easily. Having high frame rate here, up-to-date geometry, and no manual optimization of your data sets. And this all in real time. So how we were able to bring that one over to Unreal Engine, Danny's going to go in detail here a bit.
Thanks, Marcus. So based on that client, ITER, we had to try new ways of importing 3D assets into Unreal, as the traditional pipelines just weren't cutting it. So back in 2022, we introduced a mesh streaming codec called 3DFT. It was created by, I don't think he's in the room, but Dani Borra, if you managed to get a hold of him during the conference. Really smart guy. But what he did was a way to connect our digital twin iTwin platform directly into Unreal without having to do file import or export. We tested this solution heavily with clients and learned a few insights. First, the pros, streaming 3D data into Unreal, giving the users a certainty that what they were seeing is always the latest version of their asset. That definitely was a huge win for us. Then, on the other side, a few drawbacks that we did have was, as this was a test solution, the meshes being created didn't have any UVs, which meant no textures, which also meant no reality data. There were no collisions on the model, which made it very challenging for VR solutions that sometimes rely on ray casting across the world. And just as importantly, it was a new format to maintain, which brings us now to the new technology that we're using in our plugin that supersedes 3DFT. And that technology is obviously Cesium 3D tiles. We love Cesium 3D tiles. It gives us the advantage to use all of the features that the Cesium for Unreal plugin has, apart from all of Bentley's iTwin APIs into the mix. And it uses 3D tiles, which is, as you all know, the open standard format that enables us to not only bring all of the iTwin data into Unreal, but every other window, so as you'll see here. So how the plugin works, you have your 3D data. This can come from literally anywhere, so it's not just Bentley's MicroStation. You can bring it from Revit, from Rhino, from Hexagon, doesn't matter. It all gets converted into 3D tiles in our iTwin platform, and from there you can stream it or import it into your favorite 3D engine. In our case, we're going to be talking about Unreal and our iTwin plugin for Unreal. So how this works, if you've used Cesium Ion, it's a pretty similar format. So instead of having your Ion ID, you have your iModel ID. You put that into the plugin, and then it streams in the data directly into the engine. This is an airport example where we're getting that latest version of this iModel directly into Unreal. One of the APIs that we're using here is the mesh streaming. We also have the Save Views API, which is being able to saving specific points of view from the camera with element visibility. So you can store visibility of different elements for different parts. It's great for client presentations, for example. We have element properties, so you can get all of the associated metadata with each individual element, as you can with 3D tiles. And we have Synchro 4D animation, which Marcus will talk about in a few minutes. Then on the more, what you expect normally of Unreal Engine side, we have material editing. So this is kind of a big one because it allows us to edit materials directly on the Cesium tile set. It's not individual actors, it's one huge tile set altogether, and we can edit the materials individually. We can, and then decorate the scene. This is just things that you can do with Unreal. You can decorate the scene, you have object collision, and you can publish this to VR, AR, which Marcus will also talk about in a second.
Cool. All right, so let's give you an example of what we did with that one in the past already. So there's the power, or we believe in the power of mixing together different technologies like Cesium, then our Bentley part, or APIs and so on. And what we did with that one, we created a digital twin of Singapore here a few years ago, where we connected, for example, energy consumption data, transportation data, solar data, Google APIs, and so on, giving them or using then the features of Unreal Engine, the power here with creating a multiplayer experience out of that one, having custom UI, for example, or even the VR functionality on that. Or think of you have a virtual bridge inspection tool here. So you're scanning in your bridge, and instead of closing down your bridge for a few weeks and building up a scaffolding, they're using your data, your drone data, and you can really inspect every little crack inside a VR experience here. Or what about, this is for example the customer we were talking about earlier. They now using our technology to stream in these heavy data sets and to build their sequences they need for every 2 weeks here. And for example, think about as well like these VR use cases. So we provide like high frame rates here, high performance with like engineering grade models that gives you like the availability to really go around, look around in your heavy models there. And think of like in the future, what's possible with Unreal Engine now and what can be like the future as well. And also think about like these open standards, open platforms that we're really fascinated about. Let's go in a bit detail, like as we proposed in the beginning. Let's think about it, like, let's see about like how our customers are using the technology itself. So let's go into that. 1 sec.
Good here.
Oops. All right.
Morning, everyone.
Sound display.
Welcome to my presentation on Balfour Beatty Vinci's engagement visualization application working on the HS2 project. My name is Morten Price. I work for Balfour Beatty Vinci, acting as a BIM manager. Been on the project 7 years, 20 years in the industry. So, as I said, working on Area North, HS2 Area North. That's 90 kilometers of new track, embankments, cuttings, viaducts, tunnels. Working up from Longitch and Wood up to Lichfield and branching into Birmingham city centre. So it's a big project, lots of assets, lots of structures. And this presentation is going to go through how we visualise this. So in BBV, we are required to engage with politicians, stakeholders, the public, local communities. People want to see what this looks like. What will it look like? What will it look like from their point of view at home? What will it look like on their way to work? And how do we show this project in the entirety in 3D with as much realistic detail as we can? So back in 2019, we started looking at how we can provide support to our community engagement team. We started using software such as Bentley Luminati. The visuals look great. However, we couldn't federate large models. The laptops weren't powerful enough to kind of run in the graphics that we wanted. And we also had no background terrain DTM, so it was just kind of floating structures. We then started looking at using Unreal Engine. I've got a few years experience using Unreal Engine, so I thought this could be a good opportunity to bring in data because I know it can handle 3D geometry quite well. So we exported a lot of the designs into FBX files, and again imported these into Unreal Engine. And with Unreal Engine, you know, great visuals, great lighting. You can make it interactive. However, the amount of FBX files that we needed, it was too heavy. Again, you needed a super laptop to run, and it was very difficult to keep things updated. And we had to import DTM models, so a photogrammetry scan that our survey team had done, and kind of stitched together the ground ourselves, which didn't look too good. So I've got a quick video here that kind of shows what this looks like, and I both love and hate this video because at the time I was very, very proud of this. But yeah, it's just not good for what we need. So you can see we've got some trees in there as billboards. We've got the background tiling, which again is just FBX tiles. And then we've got our designs here, showing some of the embankments, some of the viaducts above the roads. So moving on. So a few years passed, the project ended up procuring Bentley iTwin design review. So we started adding our design information into the cloud where we could review it in iTwin. And again, working with the Bentley teams and the Bentley developers, we became aware of a plugin that Bentley had developed, which would allow streaming iTwin data down into Unreal Engine. So this sounded great. This sounds exactly what we needed. So we came up with an idea. We wanted to create a web-based application that streams all data down from iTwin and is imposed on some sort of background map. So we didn't want to use our own survey data because it was just too heavy. It needs to be usable on any laptop, not just powerful gaming machines. We want as realistic as possible graphics. We want to make the navigation as easy as possible for the user. And we want to be able to interrogate asset information in a visually intuitive way. So the current solution, and this is where we are today, is using Unreal Engine 5, using Bentley's 3DFT plugin that streams designs down from iTwin. We're using Cesium Ion to stream the background terrain in using the Google 3D tilesets. We can visualize key information, some BBV asset information, and we have it hosted externally so we can stream across a web browser. So this is to allow all our teams and users the ability to use the app without having a powerful laptop. So what does this look like? So this is an image of iTwin, and this is some of the designs in our iTwin model. And this is what it looks like in Unreal Engine 5. So as you can see, it really does look quite good. The Cesium 3D map really brings it to life. Unreal Engine, you know, the lighting, again, the volumetric clouds, everything's kind of brought to life. And if I show you a video recording, so we've got a map. We've still broken it up into levels because it is difficult to put all this information into one level because it's just so big. So we've come into the Birmingham district. It authenticates with my Bentley credentials, and then it starts to load the data in. I've got a map of all the assets. I can click on the list, and it zooms me straight to it. And again, I can just use the mouse. I can point and click and kind of orbit around that structure. I can click on any of the labels to jump to the next asset. So these are all a series of individual viaducts. And it is at this point very much point and click. I can just navigate to where I want to go. I can use WASD on the keypad to kind of pan around. So I've now jumped to a different area where we're more, and again, just pointing and clicking. So the bulk of the geometry has come from iTwin. Some of the ecology data, we're using CSV, XYZ positions, and we're using Unreal Engine to spawn a tree at certain, on those points. Instances just to keep the file size down. And they kind of turn on and off as we get far away or too close. So the next steps, we want to fully migrate to the latest Bentley plugin, which is using the Cesium tile sets rather than the 3DFT. We want to incorporate more ecology data as 3D billboards rather than 3D trees. We've got absolutely loads of different types of planting, shrubs, trees. So again, we want to try and get that as realistic as possible rather than just using one generic tree. And that's it. So hopefully that's been useful. Thank you all for your time. Speak soon.
Okay, that was Morten. If anyone has questions related to what Morten has been doing, I've been working with him basically every week to get this working and now to transition into the new plugin. So at the end of the presentation, you can ask me questions either about Bentley or about what Morten has been doing. Now, just to finish, a little bit of an outlook on what we're working now and what we want to achieve for the future. If you guys were in the keynote this morning, you heard all about Gaussian splats. Well, we've been using them for a while now with other technologies, not via Cesium, so with Luma capture. I'm sure lots of you have heard about that one. So we've really been experimenting on how do Gaussians come into play in Unreal. This is a very simple use case. What you're seeing here is how can you, so if you have, imagine if you have cameras in a construction site, and you're creating Gaussian splats every day, then you can have that planned versus real, visualization of how your construction asset is going. Another thing that we've been working on is AI upscale. So we've been working with a tool called Comfy UI. I'm sure lots of you have heard about it as well. To create workflows mostly for, or just trained on AEC data from still images. So imagine you're an architect, engineer, you can just put a few assets with Unreal to create a very fast scene with your engineering model, and then create this AI upscale to have a little bit of a sneak peek of how the project is actually going to look when it's finished. And what we're using, or what we like to say, is that we're using Cesium as a canvas almost to create these AI upscales. So we part from, for example, the Google 3D data, which is amazing, but it's not always super high resolution. But parting from there, we can create these really, really high resolution images with AI. And
cool. Yeah.
that's about it.
That's about it. Thank you very much.
That left. If anyone wants to use the plugin, just reach out to us. There was a QR out there.
Ah, yeah, perfect. You can scan it.
The QR if you want to scan it. You can use it. And if anyone has any questions, please approach the mics.
I think we're out of time for questions.
We're out of time. Okay, then find us in the breakout. Yeah.
Cool.
Thank you.
Awesome. Well, let's give them a round of applause. Thank you so much, guys.